In this video, I'm going to introduce the Kit Kat bar model for teaching fractions. It is exactly as it sounds. It's taking a very simple Kit Kat candy bar, using that to help students learn to visualize fractions, to help them understand the components, the numerator, the denominator of a fraction, and what really makes that aspect of our numbering system up. It's very complex. Fractions are very complex, and the models and the work, the computation gets pretty complicated really quickly for students. It's a big jump from what they've been doing in the past. And anytime that happens, actually anytime you teach any new concept in math, you should start with a very basic, simple representation that every kid has the opportunity to understand. And the Kit Kat bar works because if they've never seen a Kit Kat bar, if they've never eaten one, if they moved in from another country where they don't exist, then you can bring a Kit Kat bar in, let them experience it, show it to them, let them eat some, and they're going to understand exactly what you're talking about. And it's a reference, a visual, very strong visual reference that the students can begin to draw from to expand their knowledge of what a fraction is. So I'm going to introduce this model, but first let's talk about the model should answer the question, what is a fraction? The first thing kids need to know is, what is a fraction and why do we need it? Why is it even necessary? Most people don't like them, they avoid using them, and they find them unnecessary and unuseful. But if kids really learn how to do them, they'll find that actually fractions can simplify certain things in their life. And we do need a different representation of a number eventually, and here's what I mean. When you start learning math, you're working entirely in the number set, real numbers. And we work in a base 10 system. Within that system, we have sets of numbers that we've identified that help us categorize really the way numbers are used, their usefulness, so to speak. So the first set we work in is real numbers. So that's all numbers that are real, numbers that we can attach to real objects. There's also another number set called Imaginaries, which they'll get to way later, maybe in high school, maybe not until college if they go on into STEM. So we're not even going to deal with Imaginaries because they really don't exist. We don't count real things necessarily with imaginary numbers. And then under the real numbers, there are several other sets of numbers. There are integers and rational numbers. It gets kind of dicey. If you've ever had a pre-algebra class, you've gone through that. But the one I want to get to under real numbers, and actually would be under the rational numbers, would be counting numbers. It's really the first simple number set, and it's the number set that students start working in when they enter kindergarten. They are called counting numbers because that's exactly how they're used. They're numbers that you use to count. 1, 2, 3, 4. 1 cat, 2 cats, 3 cats, 1 dog, 2 dogs, 3 dogs. They're counting numbers. Next come, so 1, 2, 3, and then all the way up to kindergarten through 100, first grade through 125. The next number set that's introduced is the whole numbers. Now when you're teaching these in elementary, they don't introduce number sets, but I think it's important to see how this lays out because this really what we're focusing in on is the title of this number set. They are the whole numbers, and they add 0. That element of 0. The only difference between counting and whole is that element of 0. You don't use 0 to count usually. 0 you identify a set of nothing. It's necessary. So we get to the whole numbers in kindergarten. We've added 0, and that's the number set we're working in for a long, 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 long time. All multiple digit operations up through 3rd, 4th, 5th grade. We're working with whole numbers, and then in 3rd grade you start to introduce the partial numbers, which are the fractions. But we need the whole numbers to understand why we even need fractions. So let's talk about a scenario where whole numbers no longer work to describe what we're talking about. So this is a picture of a candy bar. We'll call it, maybe it's a Snicker bar, an elongated bar of candy. Now, me and a friend want to get candy bars, so ideally we're going to each go get our own candy bar because we want a whole candy bar. Candy bars are expensive though. If you've been to the store lately, they're $1.50 or higher sometimes at a convenience store. When I was a kid, they were less than 50 cents, but they're very high now. So maybe I walk into the store and I don't have enough money, me and my friend, to buy 2 candy bars, so we end up having to buy 1. We buy 1 whole candy bar. We can't buy 2, so we each have 2 wholes. We have to buy 1. And now we have to split that candy bar. That's what we say. We'll buy 1 and we'll split it, right? Well, in math, we need a precise way to describe what just happened. With a friend, it's okay. We split the candy bar. We each got everybody knows the language of half. We each got half, whether it's exactly half or not. We split a candy bar into 2 pieces. And equity is important when you're a kid eating a candy bar, so it needs to be as close to equal as possible. So 2 equal pieces. Now in a fraction, and this is where fractions come in, when a whole number no longer can describe what we got. Turner, how much of the candy bar did you get? Well, I didn't get a whole candy bar. I didn't get 1. That's too big. Certainly didn't get 2. I didn't get 0 either. I got something in between that. I got 1 out of the 2 pieces. So we break it up into 2 different pieces, and I got 1 out of the 2 pieces, and that's where the fraction is born. 1 out of 2, or 1/2. Now, in math, we need precision. We need that to be able to describe something exactly equal. When we divide something in half in math, we're saying, when we create a fraction in math, we're saying we're taking a whole unit, this is our whole unit, and we're dividing it into 2 exactly equal pieces. They have the same amount. So if I divide that by a fraction of 1/2, each person, me and my friend, are each going to get exactly 1/2 of that candy bar, the exact same amount of candy bar, which would be 1 of the 2 pieces, so 1 out of 2. So this is where a fraction comes into play. Whole numbers no longer work. Now we need a fraction. We need something else to describe what we're talking about. 1 out of 2 pieces. How much did Turner get? I got 1 out of 2 pieces. How much did my friend get? She got 1 out of 2 pieces of that candy bar. We each got 1/2 as we start to build fractional language. And they start working on halves and thirds and fourths as early as 1st grade. So kids coming into 3rd grade would have that kind of language that you could use. But they still need to understand what's going on here. Now within this, we also want to start to show them what these things mean. So this is we describe the numerator, and we describe the denominator. And they need to know those terms because they'll be used throughout their math career. What they really need to know is what the top of the fractions represents and what the bottom of the fraction represents. And I wouldn't really, as a teacher, I've never had them define things like this. I would just use them over and over again, and they'll eventually get that the top's the numerator, the bottom's the denominator. If you say it enough times, they'll commit it to memory. It'll be effectively encoded, I think. But here's where we want to start showing them with this model what these 2 numbers represent. The denominator is probably where you'd start. What does the denominator represent? What does this 2 mean? Well, I have 2 pieces, 2 equal pieces in the candy bar. So the denominator represents how we divided the whole, how many pieces we divided the whole into, how many parts probably would be a better term to use, how many parts we divided the whole into. The numerator then refers to I got 1 out of 2 of those pieces. So the numerator really describes, it answers the question, how much of the candy bar did I get? I got 1 out of the 2 pieces. I didn't get 2 out of the 2 pieces, I only got 1. So the numerator describes what part of the whole we're talking about, what specific part of the whole we're talking about. Now of course we can expand that. Say we walked in with 2 friends. We still only had enough for 1 candy bar, so now we got to divide that candy bar up into 3 equal segments. There's still 1 out of 3, 1 out of 3, 1 out of 3 pieces. So now each segment represents 1/3 of the candy bar. Because we need more precision now, there are 3 of us sharing it. So students need to understand, why does this change? Why doesn't a half work for everything? Well, the scenario changes. Now I have 2 friends and myself sharing a candy bar, so the need for precision changes. We need to split that candy bar 3 ways now, and ideally 3 precisely equal pieces. So now my denominator is 3. I needed to partition the whole into 3 parts so that I could share with my 2 friends, me and 2 friends. We each still get 1 out of 3 parts of that candy bar. Or maybe we divided it up into 3, or we bought a bar that was divided into 3 pieces, and my friend wasn't as hungry as I was, so I actually get 2 out of the 3 pieces. So I get a little bit more. So the denominator is still, the bottom is still the number of parts. The top describes how much of that I get. Now I get 2, I get a little bit more. So see, it's a precise description. Then of course the need for accuracy goes on and on. This is best modeled in measurement, with inches, taking a ruler. It starts with 1/2 inches and then goes to 1/4 inches. We need more precision, so we 1/2 inch isn't precise enough. It's not a close enough measure, so I need to go to a 1/4 inch. That's a great way to demonstrate this need for precision, or how the denominator changes for young students so they can begin to visualize it. So now enter the Kit Kat bar model. Now that we've used an even simpler representation to really describe what a fraction is. The Kit Kat bar model now is something that we're going to start to use to introduce everything that goes on before that. The division of 4 gives us more flexibility as you start to add and subtract fractions, so that you can have a little more play as you use this simple model to demonstrate. And you'll see throughout the I've set up a whole description of how to use this to teach throughout fractions. You'll see how that's used throughout as a very flexible model. But anyway, now it's divided up into 4. So each part is 1 out of 4 pieces. And I think you can see, obviously, where to take it from there. But I'd also, graphically, kids need to know what a Kit Kat bar model looks like. But you can also construct a Kit Kat bar out of Cuisinart rods. Just put the bars together. Then kids can physically manipulate it to spread it apart, to break out 1 out of 4. There's a lot of, just have kids spend a lot of time playing around with this model, breaking it apart, describing what each part means, so that you really have a solid sense that they understand what a fraction is. And then once they get that down, you want to be careful with just rectangular models. There are circular fraction models. There are many other fraction models you can use. There's linear with a ruler. You need to start exposing kids to more models. Otherwise, they'll get the idea that this is a fraction. I've actually seen a 3rd grade class where students thought that the circle with parts was actually the fraction. In their mind, that was a fraction. They didn't really have a true broad understanding of what a fraction is. So you want to mix up the models and expose them to others. But if you always come back to this very simple basic model, then you've got that strong visual representation. And I think as students start to doubt themselves, then their mind will search for this. Like, we have a fraction question, I start to panic because I don't know what's going on. The mind comes back to this strong visual representation, this model that's very simple, very basic, and they can relax in the knowledge of, okay, I know what a fraction is. Let's move from there, and let's begin to continue to try to move forward and persevere to solve whatever this much bigger problem is. Anyway, recommendation, good model. There are many others out there that are probably just as good. This is just one of them.